Hi there, welcome to our channel where we talk about traffic operations in practice. The overall intent of this video series is to reduce the learning curve for students and entry-level engineers by providing them free and high-quality learning materials in the field of traffic operations, including highway safety and travel demand modeling. The majority of content in this work is written by Professor Jiangling. My name is Amit Kumar Singh. I'm one of the contributor of this work. I'm a licensed engineer in the state of Texas. I received my bachelor's from IIT Bombay in India and my master's from UT Austin in US. Other three contributors of this work are Priyanshu Singh, who works in the field of artificial intelligence, Nidhi Kumari, who has a background in computer science and is a programmer, and Namrata Kumari. She has a background in electrical engineering and currently she is working as data scientist. Now let's get to the main content. The third method used for traffic volume forecasting is travel demand models. Travel demand models are my favorite topic to work on. They are very intriguing, mathematically challenging. There is a lot of thought process that goes behind travel demand model from the mathematical side as well as practical sides as well. So travel demand model work has been divided into two sections. In 3.3, we will look at travel demand model from the theoretical side of things, which will help us to look at how these models are implemented from the practical side of things under 3.4 and 3.5. So let's look at the background of travel demand model, which is theoretical basis for travel demand model. There are two travel demand models that are heavily used. One is called trip-based travel demand model, or also known as four-step travel demand model, and the second one is activity-based travel demand model. For past 50 years, four-step travel demand model is there and is heavily used. Activity-based travel demand models started being used. Activity-based travel demand models kind of were developed in 1990s and are still being improved through research. So they are still relatively new. In my personal experience, I have noticed the bigger metropolitan cities use activity-based travel demand models where there is a lot of transit involved, and most of the other cities use four-step travel demand model. So one important aspect of our travel demand activity-based travel demand model is several issues are still there with activity-based travel demand models, and their implementation is a little bit limited. So for this work, we will focus on four-step travel demand models and travel demand models like Transcat-based travel demand models based on four-step travel demand models. So like I mentioned, trip-based travel demand models are also called four-step travel demand models that are used in practice. The input that goes within the model is TAZ's socioeconomic data and roadway network. So the first concept to learn here is TAZ's traffic impact analysis. Uh, the geographical study areas are usually divided into small areas known as TAZs. TAZs are small region of a city for which we kind of assume to have similar or homogeneous characteristics. We will look at how the boundaries of TAZs are defined in section 3.4 and 3.5. So TAZs are small region or land area for which usually there are smaller developments inside and does not have a major road going through it. So we will see how the boundaries of TAZs are defined in future videos. But an important uh, word to remember is TAZs are simply called zones. So in this book we will refer TAZs as zones. So four-step travel demand models are as follows. Step 1 is trip generation, step 2 is trip distribution, step 3 is mode choice, step 4 is traffic assignment. So step 1 is trip generation. At this step we calculate how many trips are being generated from development and different categories of trip that are generated from the developments or from each of the TAZs here. Trip distribution, we figure out how many trips are going between one zone to another zone. Uh, when a trip starts from one zone and it goes to another zone, then the beginning zone is called origin zone and the last zone is called destination zone. So another term in traffic operations to remember is origin destination. Then the mode choice, to go from one location to another, driver have or a person has several choices. Some he can bike to the destination, he can take the transit, he can take private vehicle, he can walk to his destination depending on several factors. So those factors are considered under mode choice. And in mode choice, the trips are split among different modes that are available in the region. And next one is traffic assignment. So for the users which are going to use the roadway system, uh, there are multiple routes available that they can choose to go on, and traffic assignment is a step where between each OD pair, after deciding which mode we will use, so for certain mode we can decide among multiple routes which routes they will take and the total volumes on those routes. So traffic assignment is kind of very fascinating topic. We'll spend uh, some more time on the traffic assignment part of things. Traffic assignment is kind of used in other part of traffic operations work too. So trip generation, trip distribution, and mode choice are typically limited to travel demand modeling. However, traffic assignment is an important concept to understand because it has some good uh, implications in actual traffic operations as well. So we will try to focus on step 4 when we come to it a little bit in more depth. So let's look at the first step of the 4-step travel demand model, which is the trip generation. Trip generated and attracted by developments primarily depend on trip purpose, characteristics of development, and time of the day. So for example, if we are looking at a residential area, then the number of trips that will be going out of this residential area will be higher in AM peak, and number of vehicles that is coming in the residential area will be higher in PM peak. So the number of trips generated from developments depends on the time of the day, depends on the type of development and characteristics of development, whether it's a large residential area or a small residential area, and many other characteristics. Trips are then categorized based on purpose of the trip. So let's say from residential area, some people can go to work, some people can go to school. Let's say children are going to school, younger students are going to colleges, universities. Some people are going to transit station, some people are going to work at airport. So number uh, trips generated from the developments can have different trip purposes. So when we are trying to forecast number of trips generated, we forecast the number of trips generated for each different trip purposes, because each trip purpose have their own characteristics. So, so some of the trip purposes are mentioned here. One of them is home-based work, where people living in residential area go to office areas. Home-based non-work, where people living in a residential area go to different location for work, or they are not going for work, they are going for some transit or some other purposes. Then there is non-home based work. So there are people who are coming to work, but they are not coming from the residential area. They may be coming out of the city or they may be coming from some other places. Then there is non-home based other, so people who are not in the residential area and not going to work area as well. So there are some trips that fall under non-home based others. Then there is education, where students, children, uh, uh, even kindergarten, people going from residential area to their place of study. And then external is another important aspect. So sometimes within our study area, let's say this is my study area for entire city or metropolitan area. So the one thing I should have probably mentioned is travel demand models are built for every metropolitan area. A metropolitan area is defined as a region where with the population of 50,000 or greater, and most of the metropolitan area has their own travel demand models. So let's say this is an MPO area and this is their travel demand model. Then there will be some big routes, for example, interstate or US routes, where vehicle would be going from one end to another, and they are not gonna end up in the study area, or some of them may end up in the study area as well. So these are called external locations or external zones of which kind of produce and attracts the traffic as well. So these are external trips. So out of non-external trips, the maximum number of trips generated in a TAZ or in between the TAZs are home-based work and education. So that's a very important statement to remember. Out of all trips purposes, home-based work and education trips account for majority of trip. Um, I think based on my experience, they account for more than 90% of trips. So for apart from the external trips, which are pretty big compared to zonal trips, so external trips in itself are pretty big number. So apart from this external trip, for the other trip purposes, home-based work and education trips account for majority of trips. So let's say we are trying to estimate the trips generated and there is a lot of complications. What we can do is we can look at home-based work and education trips separately and combine everything else into others. So that's important to remember, that home-based work and education trips accounts for majority of non-external trips. Those are internal trips which are originated within the zone and are going to end within the zone, within the Campo model or within the MPO model. So the procedure used to calculate trips generated by a zone are provided next. The same procedure can be used to calculate trip attracted by a zone. So there are some procedures to figure out how many trips will be going out of the zone, which is called trip production. Let's say TP, and there are equations to calculate number of trips entering in the zone. It's called trip attraction. So below we are going to discuss the procedure or formulas to calculate trip production, but exactly the same formula or exactly the same procedure also applies for trip attraction. So the first thing we do is uh, we look at the development characteristics and define a function. So TI is a function which is the number of trips for each trip purpose. So TI is number of total number of trips is a function of development characteristics. So TI here is number of trip for each trip purpose, which is a function of development characteristics. So for a given trip purpose, TI here is for one given trip purpose. Then there will be another TI for another trip purpose, then another TI for another trip purpose. So for a given trip purpose, the trips generated by the development within a zone are calculated based on fitted curve. So F here is representing the fitted curve or the equation. So we looked at development characteristics and then use a regression equation, which we have looked in depth in section 2.2 in previous videos. So if we are looking for how to define this function and how to get the fitted curve, then we you can refer to statistical analysis video. So this is a fitted curve for one particular trip purpose. Then for other trip purpose, there will be another fitted curve, which are function of development characteristics. As an example, the number of trips generated from a residential development for home-based work is written as HBW. Home-based work is written like this. Home-based non-work is written like home-based non-work. These are standard terminologies in travel demand modeling, which we need to get familiar with. So the total number of trips generated from a residential development for home-based work trips primarily depends on number of household. It's, this is like number of apartments in the residential area, household size, how many people live within one household. That's the household size. Usually it's around 2.2. Um, it of course it varies from one location to another, one residential property to another, but this is kind of a typical number. Household income and number of workers in the household. So let's say there can be more variables, but these are four common variables that defines number of trips that are home based work. So TI is the number of trips that are home based work trips, is a function of number of household size, household income, and household number of workers in the household. So let's say um, we came up with a equation based on some study. So that's described next. So how does this function is described? So like I mentioned, we use the statistical model to come up with this function, but there are some more complications to it, which is given below. So the functional form of the fitted curve is determined using regression analysis method as described in section 2.2, which is what I mentioned. So what we do is, first a large data set is developed based on the household and travel survey in the region. So first what we do is we go and collect a lot of data, and we have usually like household data. Household data includes number of household income, number of children. There is a long list of data that comes under the household data. Household income, and how many cars they own, what kind of cars they own, uh, whether the married couple lives in there or not. So household data is like very detailed. And then travel surveys, so where they go, and what kind of, what activities do individuals in the region do, and then they also at what time this activity occurs. So those are travel time surveys. Then independent variables are subdivided into small subgroups that are highly correlated with the trips. So let's say we are looking at income. So instead of looking at income as a variable going from 0 to let's say 100,000, what is usually done is they are aggregated in a smaller group. So let's say 0 to 20,000 income range, then 20 to 40,000 income range, 40 to 60,000, 60 to 80, and 80 to 100, or and then greater than 100. And then uh, based on this data, a fitted regression curve is developed for each of this group. So let's say between 0 to 20k we have some data points like this. Then one equation will be developed for 0 to 20k. Then let's say here is 20. Let's say we have some data points here between 0 to 40. Then another set of equations will be developed. Then let's say we have some data points, number of trips generated here. So then another fitted curve will be developed. These curves may be linear, may not be linear. I'm just drawing it linear for simplicity. So what we do is we just aggregate the data into different groups. So from income there is one equation. Then based on let's say household size, there are like bunch of equations. So developing a regression model by grouping them into different groups is called cross classification regression equations. So here is an example where the equations has been cross classified by household size and household income. So here we are considering two variables at one time. So household size is 1, 2, 3 plus. Household size is number of people living in the household. Let's say average is 1. Then if the average is 1 and the income range is 1, income range is 0 to 25,000, then use this particular equation. If the household size is 2 and income range lies between, let's say, 50 to 100,000, then use this equation. So under equation, what we do is we segregate the data into different small groups, and some of the parameters that are used for segregation is household size, income. uh, these two are like the most common ones. There may be, depending on how much data is varying from each other or how much data is clustered together, we might use more categories. So as an example, this there are 9 fitted curve for 3 categories of household size and 3 categories of income. Let's say we are considering one more variable. Let's say number of workers in the household. So first we have household size. Let's say that we divided household size into 3 categories. Then income, let's say 4 categories. Sorry, there are 4 categories here. So these are 12 equations. So 4 categories. So if we are using these two, then we will end up with 12 different fitted curve. Let's say we are also using a number of workers, and let's say that we have divided into 3 categories. Then we will end up using 3 multiplied by 4, 12 multiplied by 3, 36 equations. And then we have to apply this 36 equation for each of one of these 36 equation to each of the zones. So we try to usually limit the number of variables we are going to segregate our data. So household size and household income are generally two commonly used variables to segregate the data. So let's look at now. Once the fitted curve for each of the different category is determined, these fitted curves are then applied onto the MPO travel demand model. So MPO travel demand model, and then uh, the way it works is there are a set of zones. Let's say around let's say 2000 zones in a MPO model. Usually is higher than 2000, but let's say this is my zone number 1, zone number 2, zone number 3, zone number 4, and so on. Goes up to, let's say I have 5000 zones in my model. I'm just picking up this number to show how many zones are there in a typical model. Is more than 1000 typically. So then we looked at the characteristic of each zone and then try to see under which fitted curve it goes in. So let's say household size for this one is 2, and let's say income of this household is greater than 100,000. Then we will use the fitted curve number 11, which is here. So for this one we will use fitted curve number 11. So for example, for this one, let's say household size is 3 and the income range is 50 to 100k. Then looking back to this table, let's say this is the table which we are going to use for the MPO model. So we will look at the household size as 3 and income range here. Then we will use the fitted curve 9. So this is done using software, but this is how the trip generation work. The way trip generation work is, first we figure out the total number of trips by each purpose, and for each trip purpose we have equations, and usually they are not one, usually they are a bunch of equations under what is called cross classification regression equations. So these are the part of cross classification regression equation, and this is number of trips for each trip purpose. Then what we do is we sum up we sum up the number of trips for each trip purpose to figure out total trips, and this gave us total trips attracted or produced. So number of trips generated or attracted is given by sum of all the trip purposes. So total trips generated is total number of trips from all the developments within zone. So usually, let's say I'm looking at this zone. This is my zone number one. There are some residential area here. There are some commercial area here. So this is residential. This is commercial. This is entertainment. So total number of trips are first calculated by trip purpose, and then they are summed up for each development type. So we might have different equation for residential, then different set of equation for commercial, different set of equation for entertainment for each trip type. So all these complicated calculations are done through softwares, but this is how at a fundamental level trip generation. But this is how at fundamental level trip generation step work. I'm hoping uh, it's kind of clear. So first we figure out all this e- cross classification regression equation for each trip purposes and by development type. Then we sum up uh, all the trips generated for all the developments to calculate total trips generated within one zone. So this equation is for one zone, not all the zones. So this is summing up over all the developments within the zone. Now total trip generated from one zone and total trip attracted from another zone from the same zone is summarized in something called production attraction table. So a production attraction table looks like this. So let's say this is zone number, this is production, this is attraction. So zone number one, total trips generated, let's say 1000, total trips attracted, let's say 500, and then the list of other zones in the similar manner. This table is called production attraction table. It's usually three columns. The first column is for zone, second one is for production, third one is for attraction.